Okay, let's start our lesson. No, I believe this would be similar to chemistry, where we get to know some of our measurements, the quantities, and the units. For physics, I would say that the quantities or the units are a lot more extensive compared to chemistry. So, but nevertheless, we definitely have commonalities between the two subjects. Okay, let me just quickly go through. One way I can bring some order to this set of units will be starting with what they call the 7 base SI units. All right, all these base quantities. Now, perhaps before I start on the actual units, let me just clarify the word quantity. Now, quantities are something you should be familiar with. Mass, length, k time, and I shall again stick to the base quantities. Right, there are 7 so-called base quantities. Temperature, and you notice volume and area are not base quantities, all right, because they are derived from length. Now, we also have currents. There is something called mole, but I'll touch on this a bit more later on. Right, and lastly, luminosity. So these are what we call the base quantities, 7 of them. And based on them, other quantities can be derived. So as I said, this would be area and volume are considered derived quantities. Okay, I don't think I want to write that down. Now, instead, you are supposed to remember the SI units, or sometimes what we call the 7 base SI units, which correspond to this base quantities. Right. This is a lot more important for physics than for chemistry. Reason being, you need to use SI units for your formulas. Okay, otherwise your formulas do not work. And as perhaps I mentioned to you before, there are about 50 something, right? 50 something formulas for physics for the whole of upper sec. So almost all of them, except for a handful, are based on SI units. You have to substitute SI units into your formulas to get the right answers. Now, these are SI units, and the 7 so-called 7 base SI units. Mass kg, length would be, of course, meter, time, seconds. Let me emphasize, you need to remember them. Temperature will be Kelvin. current ampere. Now, mole is mole. This is what we call candela. But again, the good news is this is not, even though it's a base SI unit, it's not covered in physics. So this one is covered in chemistry though. This is totally not covered at all for secondary school science. Now, obviously, this 1, 2, 3, 4, 5 SI units, they can be split into so-called derived units. I mean, the obvious ones would be grams, milligrams, kilometer, cm, and so on. Likewise, seconds can be expressed as milliseconds. There are other units for temperature, but I won't touch on them, so normally we stick on this. But of course, oh, by the way, just to be clear, these are still SI units. Okay, sorry, I shouldn't say that. Of course, I also have other subunits for ampere, milliampere, and so on. Perhaps you notice something common. There is, you tend to see prefixes being used. Milli, kilo, centi, milli again. So, well, you need to, okay, but let me just clarify, all these are not counted as SI units. So, let me just quickly go through the prefixes. Now, starting from meter, let's use meter. So this would be what we call the one without any prefix. Now I can go downwards. So I have millimeter. Maybe I just spelled it for you. So this is millimeter. Now this is 10 to the power minus 3 meter. Micrometer. Note how it is written. Okay. Now occasionally, you also see micro represented by U. And this is 10 to the power minus 6 meter. So this is the spelling, but this is the symbol. Then you go further down, you have nanometer. And perhaps you can deduce what is the value here. That would be 9. Further down, you have picometer. That would be 10 to the power minus 12. Now, basically, at this kind of, okay, let's just talk in terms of length. After all, meter is a unit for length. So at this kind of sizes, you're talking about microbacterial size. Right, of course, further down, you're talking about atoms, molecules, all right, electrons even, subparticle sizes. Now we can go the other way too. Okay, I can have kilometer. Let me just add the spelling in. So this is nano. This is pico. This is kilo. So this is to the power 3, no longer minus. I have mega as well. Now, differentiate between mega and milli. One is capital M, one is small m. And that makes a difference. So this will be 10 to the power 6 meters. Okay, further out I have bigger. That would be G. Oh, make sure I have the meter here too. All right, further out I have tera. Watch out for the capitalization. These are all capital T, G, M, but this is a small k though. Now, but these are the basic prefixes. However, occasionally you see others, like for example, all right, you see CM. That stands for centi. And this is 10 to the power minus 2 meter. And you see deci as well, which is covered in chemistry. So D stands for deci. And this is 10 to the power minus 1. There are others, but they are hardly seen in secondary school. There are others too. So I dare say that this should be the prefixes you need to know for your upper sec syllabus. Now, be very clear. My prefixes can of course apply to any other units. All right, for example, joule. Now, 1 joule is a pretty small value. So if I'm talking about energy, like your food stuff, they provide lots of energy. You are more likely to make use of kilojoules. Or if you're talking about even larger amounts of energy generated, like from an electrical generator, yeah, you still measure energy in terms of joule, whether from chemical sources or from electrical sources, then you're likely to see megajoules or even gigajoules. My point is, your prefixes can be applied to other units. Okay? But let's just take a look here again. Now, as I said, these are the 7 base SI units. But joule is nowhere to be seen here. All right, sorry, these are the 7 base SI units over here. This 7, but joule is nowhere to be seen. Yet, you need to know that joule is an SI unit too. Okay, so from this base SI units, you can have other kind of units, like joules. In fact, I'll give you a few examples, which you need to know, by the way. I have energy, pressure, density, force, power, voltage, of course. No, of course, I don't think I want to write more than that. There are, of course, many others relevant ones. No, these are all quantities too, though they are not base quantities. They also have their SI units. However, earlier on we mentioned what we call base SI units. So the SI units over here are not exactly base. We call them derived units. Though secondary school hardly asks about this term called derived. However, you need to know the units for each and every one of these, and of course, more others. Energy, as I said earlier, joules. Pressure, Pascal. Density, kg per cubic meter. Force, Newton. Power, watts. Voltage, volts. Okay, let me spell it out for some of them. But you may want to ask, why are they called derived units? I won't go through every single one. Let's just take a look at the simple one called density. You notice what is density? It's actually the units for density are made out of Sievert units. And it comes from kg. It also comes from length. But you cube the length to get cubic meter. So basically, all this, even though they are SI units, they are derived from the base units. A combination of them. So how the rest are derived, I don't think I want to go through them one by one, but just keep this concept in mind. Whatever the case, you have to know what are your SI units for every single relevant quantity. Now, I have to mention something else as well. So basically, let's give an example. So if I have pressure, for example, 1000 Pascal. Now make sure you're clear. This is what we call the quantity. This would be the unit, or could be units. And this is the magnitude or the value. Okay, so just keep this concept in mind for whatever quantity you're looking at. It typically has a value or magnitude, right? And it has appropriate units. Now, obviously, the units need not be SI units. They can also be expressed as, let's say, 10 to the power of 6 millipascal. Right, so, well, in this case, I still have a value or a magnitude. I still have units. Right, just note that in this case, this is not SI. Okay, whereas, this is not SI. Whereas this is SI units. So look carefully at your question. Is it giving you the values in terms of SI units or not? Okay, let's just go through a few other concepts. Now, Again, we also want to look at the apparatus to measure some of these quantities. All right, so for time, stopwatch. I think that would be obvious. Clocks, maybe. Pendulums, maybe. Now, I want you to be sure what is a pendulum. You need to know because this has a habit of coming out in the assessment. So essentially, you have a piece of string. You have mat or weights over here, usually spherical. This end is tied to something. Right. I mean, could be any fixed point here. And of course, you allow this pendulum to swing. You pull it here. You put it. You put it here. Release it. It will swing all the way there. Swing back again and back again. So that is a pendulum. Now here we just quickly mention how to measure the length, and you need to know this few apparatus. Right. Tape measure. Well, tape measure is basically you're not here, so I can't show you exactly what it is, but basically it's a tape, and there are markings on the tape, and it typically stretches for a few meters. So this would be the range. So keep this range in mind. If you want to measure something that is a few meters long, you will need your tape measure. Now, precision, in other words, the smallest interval in the tape measure is 1 mm, typically. Now, meter rule, again, keep this in mind. You are going to see this in your assessment quite often. Meter rule is now, without giving any other information, the meter rule means is 1 meter long. Okay, so if they just write the word meter rule is by default 1 meter long. Now, precision is likewise 1 mm. That would be your smallest interval. Well, how long is it? We already mentioned it's 1 meter long. So in other words, it's used to measure something of a few cm to up to 1 meter long. Vernier calipers. Now, sometimes they remove the word vernier and add in digital calipers. This is the range. 1 cm, it can't measure too small, otherwise the accuracy is no longer there. An object 1 cm all the way to 15 cm. This is a very typical range for vernier calipers. And precision is 0.1 mm. So it's, well, more precise, but at the same time, the range is smaller. Now, micrometer screw gauge, as far as I know, this has been removed from the latest syllabus, so I won't touch on it now. Now, I just want to mention a bit more about the pendulum. Now, this thing, hold on, if I allowed it to start from here, this is my starting point. and I let go, it's going to swing. We will reach the highest point here, and it goes back again to its starting position. Now, this is counted as to and fro is one oscillation. Now, the time for one oscillation is called the period. Now, get used to seeing this word period. Is a term that describes time, and the symbol is capital T. Now, yes, of course, you also use capital T for temperature. Do not be too surprised. There are common symbols that are used for different quantities. And what are the units to measure period? Well, let's stick to SI units. And that would be seconds. All right, so keep this in mind. Period for this pendulum swing is taken as is measured in seconds. Now, of course, this can be done in a practical setting as well. You may get to do this. In fact, you will get to do this in your practical session. But again, let's be very clear too. Now, assuming your pendulum is already swinging, and is already swinging to and fro, but I only start my stopwatch here at this spot. So it is going to continue to swing, maybe up here, reach the max, it goes downwards again, up, and then of course downwards and upwards, and then it goes downwards again. Now I want you to be very clear. For this case, up, down, is also counted as one oscillation. Right? It always starts and ends at the same spot, but it doesn't mean that for this case, it means that it has also gone through this spot on this particular arc of movement. Okay, so just take note, this is counted as one oscillation as well. Okay, finally, a typical pendulum can oscillate pretty fast. So it doesn't make for good accuracy to just measure one oscillation. Okay, instead, we tend to measure, let's say, 10. Right? That we quantify, we tend to measure the time taken for 10 or maybe even 20 or even more than that oscillations. Right? Because it's not going to be accurate if it just swings within a second. You have reaction time, you have observation time. Your finger does not press as fast as you would like to. So all this will constitute error in measurement. So therefore, we tend to take about 20 oscillations, measure the time, and take this time to divide by 20 if you are using 20 oscillations, and that would give you the period. So just keep this in mind. We want to minimize errors in measurement. Here is especially observation error, reaction time. As I said, one oscillation is pretty fast. So it makes sense to measure about 20 oscillations. divide by 20 to get a more accurate reading for your period. Now, one other thing that you ought to know, for a typical pendulum, the mass does not actually affect the period. Unless it's extremely light or extremely heavy. Okay, but in general, if you just take a typical mass, typical uh, ball or sphere, it doesn't affect the period. Now, what affects the period? This does. So I'll symbolize it as L. Now, essentially, keep this in mind, the longer the length, the longer the period. So get used to seeing all these symbols, capital T, small l. Now, the other parameter that affects the period is not so obvious. You can't see it from this setup. That would be gravitational field strength. Here, the symbol will be G. There are units for this, but I won't go into the units right now. So it affects the period. Okay, let me re-emphasize. Period is symbolized by capital T. There's a very precise effect due to the gravitational field strength, but in general, as your field strength increases, I mean, intuitively, you may be able to figure out as your field strength increases, do you think this is going to swing faster or slower? Greater gravitational field strength means you're experiencing a greater weight. All right, a greater force on the pendulum board. So even by intuition, you should realize that your period is going to be faster, meaning it's going to decrease. So just keep these two parameters in mind when it comes to a pendulum. Now, I would like to stop at this point. So again, if you have questions, you can feel free to post them in your Telegram group chat.